All right, we're going to start lesson 1.2 today. This is on algebraic expressions. So we're going to build on the ideas of yesterday's work with numerical expressions, but we're going to add some algebra to it today. And we're going to work on writing and evaluating these algebraic expressions. All right, first of all, we're going to start with some terminology, some definitions, if you will, to make sure that what you hear me saying, you understand the definition and the ideas behind it. First thing is a variable, and I think you guys all know this. It's a letter that we use to represent an unspecified number or value. So it's essentially a number that is it's a letter that's representing a number that we don't know yet. An algebraic expression. Okay. It's an expression. Now, when I say an expression, we had a definition of expression yesterday. An expression is a math statement that involves numbers and operations. So now what we're saying is take that same concept, an expression that involves numbers and operations, and now we're going to put at least one variable in it. So now we're going to have a math statement that involves numbers, variables, operations. Okay, so we build on that. A term, you'll hear me use this a lot. Okay, and a term is simply a number, a variable, or a product or quotient of numbers and variables. Okay, and it's a kind of, they're clustered together, they're attached by multiplication, and as we go I'll show you those and kind of point them out, but you'll hear me say what's this term, and what term has the variable in it. You'll hear me use that quite a bit. The variable term, look at there, right on cue. The variable term is the term, okay, that contains the variable. All right, so if I had 3x plus 7, the variable term would be the 3x. All right, and you'll hear me again, you'll hear this over and over. A constant term is a term that doesn't have a variable. So basically, a constant term is a number. Okay, 10 is a constant term. All right, so you'll hear me use this quite a bit. Okay, so let's look at this. Write a verbal expression for this mathematical expression. Okay, so we got to match up whatever we would write to represent this. Which one of these is it? Okay, so the key is just read it correctly. I would say, if I had to read it, this is 2/5 times m squared. All right, now I don't see 2/5 times m squared, but I see 2/5 of m squared. And what you're going to find is of mathematically means multiplication. So 2/5 of m squared. All right, I'm going to take 2/5 of m being squared. That's this. Okay, that's our answer. But let's explore this a little bit. What would 2/5 times the product of m and 2 be? Okay, 2/5 times the product of 2 and m. Well, that would look like this. 2/5 times the product of, that means multiply, m and 2. So that's clearly not the original. How about this one? The quotient of 2 and 5 times the product of m and 2. Okay, so what's that going to look like? Well, the quotient of 2 and 5 is 2/5. That's 2 divided by 5. So that's the quotient of 2 and 5. The problem is here, times the product of m and 2. Product of m and 2, that's the same thing I had here. Written different, but it's the same thing. So that's not it. And then finally, D, with another choice we had, 2/5 of m cubed. Well, what's our difference there? They said m cubed. We had m squared. Okay, so the correct choice is C. I just thought it'd be nice to point out where these were wrong and then talk about how we should write those. Okay, how about grouping symbols? All right, how do we handle grouping symbols? What does it mean to have grouping symbols? Okay, there's some terminology that we use, and I'm going to point this out as we go, that helps you know there was a grouping symbol. Okay, for example, a verbal expression, to write this out, it's a to the fourth plus. Now notice here, a to the fourth power plus, they say the quotient of. All right, by saying the quotient of, they're telling you that the next two things are divided. The quotient of 6 times b and 7. That means 6 times b is the numerator, 7 is the denominator. Quotient is division. That's what a fraction bar is, division. 6b divided by 7. So this is one way to write it. We could have just said a to the fourth power. You could just say a to the fourth. Usually that's good enough. A to the fourth power plus 6 times b divided by 7. That does the same thing, guys. 6 times b divided by 7. Okay, but when we say the quotient of, that's kind of a key term for grouping. All right, we could say the sum of, the difference of, and that's telling you that those two things should be grouped together. we're going to see some more here as we go. All right, let's take a look at this one. 2 times the quantity of y plus 11. Okay, we got to be careful how we write this. So let's just do a literal translation here. 2 times, little dot there, the quantity of. What does that mean? That means whatever I'm going to say next goes in parentheses. 2 times the quantity of y plus 11. Okay, if I simplify it, write it a little differently, it's 2 times the quantity of y plus 11. That's the simplified version. But again, we're looking at, quantity of is a grouping symbol concept. We got to catch those. How about this one? 18 increased by the product of 3 and d. So 18 increased by addition, the product of. So the product of means the next two things have to get grouped together. So we're going to group the product of 3 and d, 3 times d. Okay, now if I simply write this a little differently, I can write 18 plus 3 times d, because remember, order of operations says I'll do multiplication before addition. So the order of operations is holding these two together for me because it comes before addition. So I didn't necessarily have to have the grouping symbol here because order of operation took care of it. Okay, evaluating algebraic expressions. So whenever we say evaluate, that means you're going to substitute in numbers and simplify. Okay, so let's say I had g plus 6t. So here's where we're going to pull our numbers from. They're saying replace g with 2 and replace t with 11. So 2 plus 6 times 11. That's all we got. Okay, once I do the substitution, now this is just like what you did yesterday. Okay, so now order of operations. You got addition, you got multiplication. Multiplication comes first. So it's 2 plus 66. Remember, rewrite everything. 2 plus 66. And then 2 plus 66 is 68, and we're done. Okay, that should be your work. Come over here. Different one now. 2 times t plus 3 times g divided by 4. So parentheses here, I got to get this to be a single answer. Got to work it down to one number, and then in the end divide it by 4. That's what the grouping symbols do. Let's go ahead and substitute in. So t is 11, g is 2. Okay, I had r up here, didn't even use it. Okay, let's go ahead and do the work in parentheses. I got multiplication, addition, multiplication. So I'm going to do this multiplication first and then this multiplication second. And because of that, I could really do them at the same time because they're not going to affect each other. Still in parentheses. So 22 plus 6 is our 28, and 28 divided by 4 is 7. Bam, got that one. This should be the work though. Substitute, follow order of operations, do the work right down the page. Let's take another look at some of these. Now we're going to throw in some exponents, make it a little bit more challenging. So this expression, this is a variable expression, right? It involves operations and variables. We're going to replace a's with 8, b's with 4, c's with 16. So guys, this is a squared. So whatever this I'm putting in place of a, I'm going to square it, multiply that by the b, multiply that by the c, and then subtract whatever b is squared. So we can just go ahead and plug those all in. And now let's look at order of operations. Okay, grouping symbols. That's always first. But this really isn't a grouping symbol as much as it is a multiplication symbol, the way I wrote it, right? There's nothing inside this parentheses to do. It's just a number. So it's really not a grouping symbol in terms of grouping an operation. So I'll go next. Next in line is exponents. So I got 8 squared right here. So I'm going to do that first. 8 squared means 8 times 8. That's 64. Now I'm going to do this one second because it's, also an exponent. I go left to right. So this would be next. This is 4 squared. That's 4 times 4. That's 16. So I've taken care of exponents. The next thing we look at is multiplication, division, left to right. So as we look here, I got 64 times 4. I'm going to do that multiplication first. That's 256. That's going to get multiplied by 16, and then we'll subtract 16. Okay, so 256 times 16, 4,096 minus 16, and we get 4,080. Okay, so just follow the order of operations one step at a time. This one, okay, now this is written as a fraction. And what I want you to understand is whenever I have a fraction like this is really being grouped. So the numerator, 2c minus b squared, that's grouped. I got to work this down to a single number. A times b is kind of in parentheses. I got to get a single number there. And then once I've got the numerator down to one number and the denominator simplified to one number, then I'll do that division. So these are separate until I get them down to one number. First step, substitute. So in place of C, I put 16. In place of B, I'm going to put 4. And in the bottom, I'm going to put 8 times 4. All right. Now, order of operations. Is this a grouping symbol? Well, it's parentheses, but there's nothing to do inside of it. So it's really a multiplication symbol. Same thing down here. This is really, it is a parentheses, but there's no work in here. It's just showing I got to multiply. So actually, the first thing we would do is the exponent here, right? Exponents come before multiplication, division, or addition, subtraction. So we'll do that. Okay, 4 squared, 16. Now, in the numerator, I got to do 2 times 16. And in the denominator, I could do 8 times 4. Again, remember, I got to work all of this to get a number and all of this to get a number. Then I'll do the last step. So in the numerator, 2 times 16 is 32. So 2 times 16, 32 minus 16, that's in the numerator. 8 times 4, that's also 32. That's in the denominator. Okay, got to finish this part. 32 minus 16 is 16. So I got 16 over 32. Now I can do my division. It's going to be 1/2. Whoopsie. It's going to be 1/2, or you could have 0.5. A calculator would tell you it's 0.5. Reducing to a fraction is just as good. All right, so that's a look at substituting and simplifying algebraic expressions. So again, there's more to be looked at, and there's some applications and some other things you can do online. If you go to your McGraw-Hill site and look up this lesson, there's all kinds of sorts of things you can do. Make sure you get on today's homework, get it done, take a picture of your work, submit it. You always got to show work. All right, have the work to go with it. That's all I got. So I'll let you guys get going on homework.